Alright, this is your second to last lesson on any new content. This is about the Hungarian algorithm. So this first board is just background, so I can link back to your lesson from last week. Last week we saw how we could represent assignment problems with these graphs and with matrices. I then asked you to try solving an assignment problem by eye, or trial and error. And although one of your classmates did find the right answer, it might not have been the most efficient way. It might have taken longer than you should have. So clearly, in a test or exam situation, we need a more systematic method of solving assignment problems. That method is known as the Hungarian algorithm, okay? This will get the same answer that your classmate got, but you'll know that it's the right answer. So what I'm going to ask you to do is get these steps down so that you can practice using them. You don't get a cheat sheet. You don't get a cheat sheet for your test. You just need to get good at applying these steps. So what I think I'll do is I'll give you a few minutes. Can you get these 4 steps down? There's a 5th step on this board here. But the best way to go about it is to actually show you how these steps apply when we apply it to a matrix. So what's your first step? Find the smallest number in each row of your matrix and subtract it from the other numbers in its row. Step 2, you find the smallest number in each column of your matrix. Subtract it from all the numbers in that column. Step 3, using horizontal and vertical lines. So step 3, it's going to feel very much like noughts and crosses. It almost feels like a little game, okay? If you've been practicing the networks stuff and you got good at that, you might feel like that's a game too. There's not really any maths here, it's just a set of steps. This is the trickiest step, okay? Using horizontal or vertical lines, you need to cover as many zeros as possible with each line that you draw. If the number of lines that you draw is equal to the rows in the matrix, you skip over to step 5, which is on this board. If the lines drawn is less than the rows in the matrix, you do step 4. In step 4, there's a series of things that you need to do. I think it's best that I actually just show you that with a matrix, okay? So what I'll have is I'll put this over this side. Now I'll demonstrate it with our swimmer's situation, and then you can go on to step 5, what you can see while we're doing the example. So we had this exact same example last week. The times for 4 swimmers in a team to swim 100 meters of 4 strokes is shown below. Alex, Bruce, Carl, Dave, swimming backstroke, breaststroke, butterfly, freestyle. Those are their times in seconds to swim 100 meters. You might remember that your classmate found that that was the optimal solution by eye. But that was the only definitive way that I told him it was right is because I told you it was right. But I want to show you this systematic method so that you can do it in your test and you're not questioning everything, how we can apply that to this. So find the optimal assignment of swimmers, 2 strokes to get the fastest overall team. In your exam, in your tests, you can do the steps on the starting table, okay? I don't have any room here to do that. So I rewrote that table up here, okay? So what is step 1? Identify the smallest number in the row and subtract it from all the other numbers in that row. What's the smallest number in the top row? Sorry? 52. So I'm going to write, my working out is I'm going to take 52 from everything. What's the smallest number in the second row? Smallest number in the third? Smallest number in the fourth? 48. People stuff up and lose marks in this topic, not because they didn't do what I taught properly, it's because they stuff up subtraction. That's why they lose their marks in this topic. I've done it for like 7 years, okay? So my suggestion to you, because I suck at subtraction too. I always use a calculator to check subtraction. You don't have a calculator. The way that I do subtraction is I count up. If I want to take 52 from 56, I go back the other way. I go 52, 53, 54, 55, 56. So the subtraction is 4. So what I do is I take all of those, I take that from all of the numbers there, so that's 4. 59, take 52. The stuff that's less than 10, you should be able to do in your head, but if not, that's fine. Count up. 52, take 52. 0. 53, take 52. 1. Next one. This is where the counting up is more useful. Okay? So if I count up from here, 49 to 59 would be 10. 59, 60, 61, 60, that's 3. So that 62 take 49 is going to be 13. That's my suggestion to you, because you have no calculator. Count up when you're subtracting. 67 take 49. I suck at subtraction. So 49 to 59 is 10. 59 to 69 would be 20. That's 2 above this. So what's 20 take 2? So 67 take 49 is going to be 18. What's 49 to 59? 49 take 49. 0. 55 take 51. This is a bigger one, so I'll do my little technique. 51 to 61 is 10. 61, 62, 63, that's 13. 58 take 51. 51 take 51, 0. 58, 48. This one, not confident. 48 to 58 is 10. 58, 59, 60, 12. 48 to 54, that's 6. 48, 48, 0. Have we applied step 1? Have I identified all the smallest numbers in each row? Or did I take them away from every number?
Yes.
So we went across ways. What's step 2? Identify the smallest number in each column and then do the same thing. So we're going vertically this time. What's the smallest number in this column?
4.
Smallest? Smallest including 0 is a number. So I'm going to take 0 from this. I'm not going to do anything with that column. What's the smallest number in this column? Rewrite it. 4 take 4. 13 take 4. 4 take 4. 10 take 4. 6. 7 take 7. Nothing. 18 take 7. 11. So I'm not confident. I don't know if this off the top of my head. I'll count up. 7, 8, 9, 10, 11, 12, 13, 6. 7 to 12. 5. Am I doing anything to these columns? I'm taking nothing from it, so they're going to stay the same. 0, 10, 7, 6, 1, 0, 0, 0. Trickiest part. It's like noughts and crosses, like I said. I want to use horizontal and vertical lines to cover as many zeros as possible with every line I draw. What's the most number of zeros that I can kill with one line? Is there multiple ways to do that? It doesn't matter what order you do it, just as long as you're hitting the most number of zeros as possible. So I'm going to do horizontal. What's the most number of zeros I can get in one line next? Still 3. Vertically. What's the most number of zeros I can get now? 2. It could be vertically, it could be horizontally, it doesn't matter. As long as you're hitting the most possible. How many lines did that take? Are there any zeros left that I haven't covered up?
No.
How many lines did that take?
3.
3. If the lines drawn is equal to the rows, we go to step 5. If the lines drawn is less, which is what we've got here, we need to go to step 4. How many rows do we have?
4.
How many lines did I take?
3.
So I need to do step 4. Find the smallest uncovered number in the whole thing. What's the smallest uncovered number here?
5.
Smallest uncovered is 5. I'm going to put a little circle around that. I subtract it from other uncovered numbers. So can you see there's 2 stripes of uncovered here? I add it when something is double covered. How many times have I put a line through this 1 here?
Twice.
So I add it to that. How many times do I put a line through this 0 here? So I add it to that. If something's single covered, I leave it alone. And then after that, I retry step 3. So, what do I do with this single covered 0? Leave it alone. So rewrite. So leave, add. Did I apply those rules correctly? Are these uncovered? So what do I do with the 5? Subtract it. 9 take 5 is 4. 11 take 5 is 6. 10 take 5 is 5. How many times has that been covered?
Once.
What do I do with it? Leave it alone. Single, so leave. What do I do with the double covered? These are uncovered, so 1. What do I do with this? Okay, we applied step 4. I try step 3 again, which is the line covering. What's the maximum number of zeros I can hit?
3.
Maximum number of zeros I can hit in one line.
2.
Which one?
3.
Vertical here. Maximum number of zeros I can hit to what? This way or this way? It really doesn't matter as long as you're hitting the most. So I'm going to do the horizontal here. What's the most number of zeros I can hit? Still 2, but vertical. How many lines did that take?
4.
Is that the number of rows?
Yes.
So now we do step 5. Circle the most isolated or alone zeros. How do I do that? You check if it's alone in its row. If it's alone in its row, you circle it. Check if it's alone in its column. If so, you circle it. If you can't circle the zeros on the first pass, do the other ones first and then come back. So you're looking at me like, what the hell is he talking about? Okay, is this 0 alone in its row?
No.
Is it alone in its column?
No.
Is this 0 alone in its row?
No.
Is it alone in its column?
No.
Is this 0 alone in its row?
Yes.
Is it alone in its column?
Yes.
Is that 0 alone in its row?
Yes.
Can you see how it's matching what your mate did? Sorry, I can't say your name. Alright? Is that 0 alone in its row?
Yes.
Is that, well, the last one we can't choose according to that rule, because is this 0 alone in its row? Is it alone in its column? But have we already assigned Alex to do butterfly with this 0?
Yep.
Have we already assigned Bruce to do freestyle with this 0?
Yep.
Carl to do backstroke with this 0? There's only one more person to choose and one more stroke to choose. Because Dave hasn't been chosen, and what's the only stroke left?
That's true.
So when I apply that pattern of zeros to the original matrix, that's the minimum. Okay? So if you're answering that question, therefore, fastest team is Alex doing, what was this one? Butterfly. Bruce doing freestyle. Carl doing back. And Dave doing, I'm literally going to write rest up here. That's fine, because that's what it's about. Can I give you like 5 minutes to get this down? That finds the minimum. And then I need to do maximum, and then I'll leave you alone, okay? Keep the noise down because that's still recording. That'll be up on YouTube. But make sure you get that example down because I need to erase it for the maximum example. What I'll do is I'll put these steps over here so that if everyone has stuff, they can start getting the finding a maximum notes down. What I'll do when you're starting to do your exercises, I'll go through your stats test with you individually. But when we sit, can you sit like across? I got that hand, foot, and mouth from my face looks all messed up right now. I don't want you to see. Good.
This Thursday.
The staff versus student netball game for Year 12s is on Thursday. If you wanted to sign up, Miss Sharon. Couple of minutes and then I'll do the maximum example. If you missed something, just remember there's already a video on your timeline. This is just for the subs. Just a reminder to you as well, in your test, that table will be already written. So you can do this subtraction stuff on the printed page. I only rewrote this because I don't really have space to do it there, okay? 1 minute and then I need to replace that example there. All right, so when you do Hungarian algorithm, it finds you the smallest total. So you're finding the minimum. You're going to have questions in your exam and in your test to find the maximum. So I haven't given you a tool for that. Literally, to find the maximum assignment, you do one extra step. What do? You invert the starting matrix. So how do I do that? I get the largest number in the matrix. I take away all of the numbers from that largest number and then rewrite that in. When I rewrite the matrix, it's going to be flipped. Okay? Then when I apply the Hungarian algorithm to that flipped inverted matrix, that's going to find me the maximum assignment. Alright? So I'll give the example here. I'll erase this. We're going to do the same thing. I don't want to, what you'll notice in your textbook is there's not very many exercises because it's actually kind of tricky to make situations that work properly, okay? I don't want to waste any of the examples in your book, so I'm just going to reuse this, okay? What would the example be? Reuse the swimming example. It is 2023 and the coach was asked to run the slowest team because we like losers to win too sometimes. Alright, so we want the slowest team now. How do I find the maximum? I need to invert this. How do I invert it? Find the largest number, take everything away from that. What's the largest number in that whole matrix? Sorry? Yep. I'm going to take everything away from 67. So, inverted. What's 67 take 56? Go back the other way. Go 56 going up to 67. 56 to 66 is 10 plus 1. So 11. 59 to 67, what do we have? Huh? 8. 52 to 67?
15.
Yep.
5. 0. 8.
49, 59. 18. 55, 65, 12, 64.
9.
51, 61, 16. 58, 68 would be 10 minus 1, 9. 60 to 67, 7.
13.
Huh?
13.
13. Next.
19.
So do you agree that this matrix that I've rewritten here is this after I've taken it from 67? What do you notice about that? The largest number before, what is it now? Is it the largest number anymore? It's the smallest. What's the smallest number now? It's the largest. So if I apply Hungarian algorithm to this, it finds me the maximum. So Hungarian algorithm, I'm going to ignore those steps. What do I do first, rows or columns? Rows. What's the smallest number here?
8.
Smallest.
0.
Smallest.
3.
Smallest.
7.
Someone said, did someone say 11? 7. Rewrite it. 8, 9, 10, 11. 3. 8 take 8. 0. 7. 6. I take nothing from that line. 5, 0, 8, 18. Take 3 from this. 9, 0, 6. 13. Take 7 from this. 2, 0.
6.
Yep, 6 and 12. I've done the rows. What do I do now? Columns. Smallest number.
2.
Smallest number.
0.
Smallest.
6.
Smallest.
6.
Rewrite. 1, 3, 7, nothing, 0, 0, 0, 0. 7 day 6, 1, 2, 0, 12.
7.
That was the rows and columns. We do the line elimination now. What's the most number of zeros I can hit with one line?
4.
Only one way to do that. What's the most number of zeros I can hit in one line?
3.
Horizontally. Most number of zeros I can hit with one line right now.
2.
Is there 2 different ways to do that? There's like 3 different ways. But as long as I'm hitting 2. Okay? The only way that you would do this wrong is if you did that. Because how many zeros am I eliminating there? Only one. But if I hit this, that's 2. Is there still a 0 there?
Yeah.
What's the only way to do? I could go horizontally, I could go it doesn't matter. As long as I'm hitting 2. How many lines did that take? Is that equal to the rows?
Yes.
So I can do the identifying alone zeros now. Is this 0 alone in its row?
No.
Alone in its column?
No.
Leave it alone. Alone in its row,
Yes. No.
but alone in its column. That's alone in its column. Alone in its row,
Yes.
alone in it. That's already selected, so don't waste time looking at this. Because that's already taken up in that column. Is this alone in its row?
Yes. No.
Is it alone in its column?
No.
Leave it alone. Is this alone in its row?
No.
Alone in its column though.
Yeah.
So do I need to think about choosing that one? This is the third down and the third column along. So if I wanted the slowest team, therefore slowest team, what's Alex doing?
Freeze.
Alex, Free, I'll write the names, Bruce, Carl, Dave. What's Bruce doing?
Rest.
Rest. What's Carl doing? Butter. What is Dave doing? That's how you do maximums instead. Okay? That is basically the second half of your topic. After networks, where you're drawing your little spider webs, this is what you do for the remainder of the topic. Your last lesson on Friday is just about, have you noticed that all of our matrices have been squares, 4 by 4? If you get a rectangle, what do? Well, you add a line of zeros to make it a square. Then you do the exact same thing. Okay? So we're basically done. I'll still teach it on Friday. I'm not going to skip that. But that is your topic done. Alright? Your homework now is to the end of 12B.3.